Today's speaker is Dr. Mark Doubell. Mark is a biological oceanographer, and he's based at an organisation called SARDI, the South Australian Research and Development Institute in South Australia. He's got expertise in biophysical coupling in plankton, and since 2019, Mark has led the oceanography sub-program at SARDI. He manages a team of oceanographers and technicians that are really in support of industries in South Australia that use the ocean. That includes fisheries, aquaculture, and even things like desalination plants that are using the ocean. And Mark's specialty is in hydrodynamic modelling. And you'll see during this talk why that's a skill set that has become increasingly in demand as we manage things like harmful algal blooms. So thank you, Mark, and welcome. Would you please take it away?
Excellent. Alistair and Jody, thanks for the opportunity of talking today. I believe I'm going to give an overview of the unprecedented harmful algal bloom that we're still impacting our region here in Southern Australia today. I'm going to flick through slides reasonably quickly because I believe we want to leave time for a broader discussion of ecological forecasting and how it might deal with HABs moving into the future. So without further ado, first up, because I'll probably run out of time and forget the important thing, just a general acknowledgement at first. The size, the impact of this harmful algal bloom has required a response and contributions across state government agencies here, and also researchers, and as I'll show in the talk, citizen science. So I just really want to acknowledge all of those contributions to the broader response and to this talk, and you'll see that my talk together is pieced together with contributions from several sources listed on the page here. So I thank everybody very much. A general background, I'm sure most people know, we understand the importance of microscopic algae, phytoplankton. They underpin our aquatic food webs, and they provide energy and nutrients for all other ecosystems. And here in Southern Australia, they really underpin the rich fisheries and aquaculture industries that we have, as well as our biodiversity. Harmful algal bloom species are part of our natural occurring algal communities, and they typically exist in low numbers and in an ecological balance, both within the water column and the sediments. Unfortunately, at times when conditions become favourable, background populations of harmful algal species can lead to them rapidly multiplying and cause bloom events. In some circumstances, toxins produced by harmful algal blooms can then impact both water quality, aquatic life, and have human impacts as well. I guess pretty topical for this group is the cause and duration of harmful algal bloom events depends on multiple factors, and while we have a general understanding of those factors through the literature, it's not possible to predict both their onset or duration or decline ultimately. So as a general background to our region, and I should have really put a map of South Australia in the talk, we've had three unprecedented marine events that have impacted our region over the last few years. And these come back to some huge Murray flood discharges from our largest river into the region, the largest input since 1956, a couple of years ago. That was followed by our largest natural coastal summer upwelling, which put a large amount of nutrients and cold water onto our shelf and into our coastal zones. And this was followed straight after by the largest marine heat wave to impact Southern Australia, which occurred between September 24 and June 25. So these events are hypothesized to have potentially contributed to the current HAB that we're experiencing, and are being investigated by my group and others towards to see if we can tease out those contributing factors. I'll just mention that the particular bloom of Corynea species affecting our area is not new to the area. The last major one occurred in 2014 in a small embayment. So it's not novel in terms of its of being new to the area, but it is in terms of its size, duration, and impact, its current bloom. So just a couple more graphics on those contributing factors, just to get an understanding of the scale of these events. I'll start here on the top right. This shows an area, basically here where the River Murray flows out and meets the ocean. And in 2023, we had an anomalously large outflow, the largest, as I said, since I think it was 1956. This shows the peak outflow. This is a time series of outflow from the barrages in megalitres a day from 1997 till present. This shows that outflow occurring there. So it's not a novel event, but it is one of the largest on records, and some of the numbers up here just show the quantity of inorganic and organic matter that came out through that event. As I mentioned, this was followed by a large upwelling. Here we have sea surface temperatures from remote sensing used to detect upwelling. These are correlated with high nutrient inputs into our coastal zone. And this shows an example from one of our bottom moorings off the bottom of Kangaroo Island here, being blue. They're just showing how cold and prolonged that nutrient enrichment event was compared to recent previous years, with temperature differentials up to 6 degrees at different times of the year. And as I mentioned, this was followed by an enormously large marine heatwave event that affected our region. This is March, showing those temperature anomalies around greater southern Australia. And through the Marine Heatwave Tracker website, we can have something called the cumulative intensity, which I'm sure Alistair can answer better than me, but takes in effect both the intensity and the duration of the event. And if we have a look at that time series, that recent event really did have a large impact on the region of interest. Okay, so I'm going to move on now to some remote sensing. We use chlorophyll due to the general remoteness of the area and not a lot of in situ observations, particularly of water quality. We've had to rely on remote sense chlorophyll as an indicator to understand the movement of the bloom. So what I'm showing here is the magnitude of, this is an actually monthly average, this is daily average, chlorophyll A increases compared to the 21-year median conditions or climatology. So the animation starts off on the 1st of January and takes us through nearly to October. And in mid-March, you'll see the blooms start to form in this area of our Fleurieu Peninsula, indicated by the arrow there. So this is pre-bloom conditions. And as we come into March, we see the blooms start to really take hold on the foot of the Fleurieu Peninsula, transported into, this is Gulf St. Vincent, by the prevailing winds and oceanographic circulation. And as we progress into winter time, it's moved around with the changing winds and ocean circulation onto our metropolitan coast here. And we also see another bloom event move north up our larger inverse estuary, Spencer Gulf. And this will take us up to the current, virtually the current status as of about a week ago. So here's some monthly average maps. We have overlays here in the pink circles of Karenia detections undertaken by water sampling across those different months. So conditions in February, moving on to the initial detections and the initiation of the bloom in March, and tracking it through our months and our seasons to our presence time in September here. As you can see, some of the detections of Karenia indicated by the pink circle have been so high in some of our inland waters connected to our coast that they pretty well overtake the map. There's also reported fish kills, which I'll show you some more details of late in coming slides. So moving on to that, to understand the impacts, it really is unprecedented, and it's ongoing in terms of the fish mortalities that we've seen. There's been impacts across all trophic levels. Over 550 different species have been identified on shore, and that correlates with thousands of marine animal deaths. and they've affected both commercial, iconic, and protected species. And there's an example of all of those species there. And we have additional concerns that they may have had an impact on larger trophic species such as sea lions, dolphins, and seabirds, etc. So it's an ongoing event. While some of the nearshore impacts are visible, we're still undertaking surveys to know the deeper water impacts and resolve those. But the impacts have not just been on those fish and the nearshore communities. It's affected regional communities and centres known for recreational fishing and their tourism. And we're still undertaking studies to understand and track the long-term biodiversity and ecosystem impacts. Some examples of some of the significant mass death events include those on the Fleurieu Peninsula, where we had mass kill-offs of pippies or cockles, and also thousands of dead octopuses as well. On Kangaroo Island, there's been mass deaths of fiddler, different types of rays, and sharks, right down to flounder and seabirds, and also affecting shellfish die-off in the order of tens of thousands in mussels. Across different regions on our York Peninsula, which all of the regions won't be known to everybody here, there's been other widespread mass fish kill events, and that's affected our local metropolitan beaches near Adelaide, where most of the population's based, where we've seen impacts from sharks and rays to more common smaller fish species. So this provides an example of some underwater images taken before the bloom at different locations that have been impacted by the bloom before in 24 and currently throughout 2025. So you can see some of the impacts on the diversity of marine life and some just even on the watercolor and the clarity that we're having on our marine ecosystems. Citizen science has played a huge role. Obviously, South Australia is regionally remote. So these are reports to the iNaturalist website. So there's been over 50,000 observations, over 550 species reported, and over 1,000 observers. And these are some of the common species that have been reported impacted, correlating with the bloom areas. So another area of impact has been our shellfish growing, aquaculture growing regions. We have a shellfish quality assurance program in South Australia. It's been in place since 1996, and it's basically to monitor and manage shellfish growing and harvesting areas to make sure they're complying to national food safety regulations. This program is responsible for the opening and closing of waters in harvesting aquaculture areas based on those food safety regulations. And it also identifies the need for harvest areas to have a biotoxin management plan. And so this is an essential requirement for market access in the seafood industry. So prior to this event, neurotoxin shellfish toxins have not been found in Australia, but SASQAP conduct regular monitoring to be able to detect harmful microalgae and the associated marine biotoxins in the shellfish areas. And then when the biotoxins are detected close to the regulatory limit, monitoring increases and harvest areas are closed to protect human health as a precautionary measure. So correlated with the footprint of the chlorophyll images and the detections that I've shown you of the Karenia species, we've had broad areas on those corresponding with closures, red being areas still closed, green being areas around Port Lincoln which have been closed and are now reopened, and larger areas along our western coast of the Eyre Peninsula that have remained open and unaffected by the bloom. So since the commencement of the bloom, my group's been providing regular updates using available tools to advise on the presence and potential trajectory of the bloom. And these updates have really been used around using chlorophyll imagery tracking ocean temperatures because the marine heat wave was a factor when the bloom took off. And we also use forecasts of the ocean circulation to advise on the potential trajectory. So this is some tip or a regular chlorophyll A remote sense products available from the IMOS Ocean Current website. We understand there's limitations, particularly in our shallow water ecosystems, with using chlorophyll as an indicator of biomass due to optical reflectance issues and turbidity issues. So what we've been able to develop is some very simple products to look on areas where we think there's a growth or accumulation of chlorophyll and areas of decay. So what we do here is we take the daily images and we subtract off the median of the previous 10-day to remove some of those shallow water biases, and it leaves us with an anomaly of plus or minus 1 microgram per meter cubed, but red showing areas of increase in chlorophyll and blue showing areas of decrease in chlorophyll. So that's one of the tools we've been using to advise on where the bloom may be, where to focus monitoring, and where it might be affecting fisheries or aquaculture industries, or even public recreational activities. That's used, as I said, in combined with both ocean forecast models and regular water sampling tests. One of the limitations of chlorophyll remote sensing is it doesn't detect harmful algal species per se. So the state government's implemented an increasing amount of water quality testing to identify harmful algal species. And when we combine that with the chlorophyll and short-term model forecasts, such as this one here, we can get an idea of the movement of the of water parcels containing the algal bloom over periods out to about 5 days. So this has been particularly useful in understanding the connectivity of any detections around this area with our national heritage and iconic species such as the cuttlefish aggregation up the top of Spencer Gulf here. So blue here is the wind, and the particles simulate the movement of water masses due to both winds and tides and other factors over a period of 5 days. So this has been really helpful in advising on the mitigation measures to potentially protect this cuttlefish aggregation, as an example. Other tools we've used for remote sensing is looking at time series of chlorophyll compared to climatology over time. And here's an example where we have a look at our region. We divide it up into different areas, and we compare the chlorophyll concentration with the long-term climatology over 30 years. So up till recently, you can see this area of Gulf St. Vincent in the west here has been impacted by the bloom, but is now trending down over the last month or so, whereas the Gulf St. Vincent, where Adelaide is here on the metropolitan coast, is maintaining a high level of chlorophyll A, and that's correlating with ongoing Karenia detections, whereas regions like the southern Fleurieu Peninsula down here, where the bloom was first initiated, had an initial peak and then has been hovering slightly higher than climatological averages. We also use information from our hindcast models and long simulation runs to understand what might be coming up in the future. So these are 6-year averages, mean circulation taken from 6-year hydrodynamic model runs, and where we can see the mean circulation patterns. In winter here, September being winter, particularly in Gulf St. Vincent, we have generally a clockwise circulation driven by the winds, and we can see that it's strongly influenced the distribution of the bloom over time. So we can use these type of hindcasts to understand, as the seasons change, where the bloom may be moved to. So moving forward, there's been state and federal funding related to a science plan to respond to the HAB event, and that really is based around 3 major capabilities. That's algae identification and developing an Australian national testing capability for brevetoxins. Until now, The only certified capability has been in New Zealand through the Cawthron Institute. So there's been delays in sending samples, well, time delays in sending samples off and receiving results just to the nature of that being in New Zealand. So we want to develop capability within Australia and the state there. There's a large piece of work going, the ongoing impact assessment for both fisheries, and that includes an understanding of using ecological modelling and the collation of the citizen science data that I showed you. And my group's involved in developing an early detection and monitoring system, and that includes potential to lead into forecasting. So just a little bit more on that. If we have a look, this is an area of the chlorophyll A anomaly averaged over the period March to July. And the yellow here indicates regions where we'll deploy some monitoring buoys, early detection and monitoring buoys. And these locations are based on both the source origin or potential ignition points, with the key ones being around the Fleurieu Peninsula. Excuse me, Port Lincoln here, where there's been a history of Oceania blooms at a smaller scale, and also on Coffin Bay over here further to the west, and also taking an understanding of the oceanographic circulation by putting out a network in other areas. We can actually get some understanding of where things might move to if detected at one site as compared to another. And they also sit adjacent to key aquaculture shellfish locations. So just in a little bit more detail, part of the early monitoring and detection will include some state-of-the-art sensors, which will be able to provide data in near real time. Among those include a harmful algal bloom sensor, which works off the fluorescent emission spectrum properties for Corenia and Shadonella species. But in recognition that there may be other HAB species impact our area or other areas into the future, we're partnering with CSIRO Aquawatch, and I believe Nagua gave a talk not long ago to this group about the Aquawatch initiative, and that'll integrate sensors like the hydrospector, which are more broadband ocean color detections to develop improved satellite products and pull in high resolution data streams to train artificial intelligent forecasts. So a little bit more on that. That early detection and monitoring, this harmful algal bloom sensor, again, it's a little bit more details on how the sensor work. It basically uses the ratio of emission at 600, fluorescence emission at 690 over 670, which has a distinct signature for Corenia and Shadonella species over others to provide an early detection of those two species, whereas the water quality combined with the water quality sensors and the CSIRO hydrospectra, which provides a broader fingerprint of ocean color to be detected. We're also looking at potentially including the monitoring system or integrate into it an imaging flow cytobot. This is basically an underwater microscope that provides near real-time in situ identification of phytoplankton groups and species and their respondents. And it does that using an AI-trained image classification techniques. So the initial ideas are to use an imaging flow cytobot to both validate and train these collection of sensors on a peered platform, but possibly to also integrate them into some research vessels to underway field surveys to get a broader knowledge of harmful algal distributions in our water over time and their relation to physical drivers. So pulling those together, we also plan to integrate them with the ocean forecast modelling that we've been able to provide in conjunction with the Bureau of Meteorology, bolster the forecast up to 10 days to provide a little bit longer lead times for early warning. And this is a similar approach used overseas in other areas such as the United States, to where they integrate water quality monitoring and hydrodynamic forecast models to map the trajectories with the different colours showing the trajectories of detected Coronias of different concentrations. So that's to my last slide. For people interested, there's a state government website, algalbloom.sa.gov.au, that provides an update on all activities, including the situational updates that I talked to you about. So I think I've got through that pretty quickly, Alistair.
Excellent. Thank you, Mark. I hope you can hear the virtual applause from the people on screen.
Well, thank you very much. It's a bit of a hobble together of many people's input, so thank you.
It sure has. Invite the audience to ask Mark any questions, either using the chat function or just by raising your hand or jumping in. Let's see what works for us today. Hello, Alex Sengupta.
Hi, Mark. Thanks very much for that. That was really interesting. You showed this animation of the chlorophyll sort of starting in that southern bay and then suddenly jumping to the northern bay. I was just wondering, is there a connectivity between those? Did you use the Lagrangian techniques to look at connectivity, or is it just that the algae is dormant there and the conditions become right and it suddenly blooms up?
That's a very good question. That connectivity piece of work's still an ongoing piece, just to be able to get a large time series to do that hindcast with recent forcing. But initial thoughts is this is a separate initiation area rather than connectivity based on, but I'll leave it to proving that correct or incorrect once we've done some longer term hindcast modelling.
Thanks.
Hi, Rupert.
Hi, Mark. Lovely to see you again. I used to work at SARDI. I appreciate where my question's probably disappearing off the modelling ecological forecasts, but how do you reckon we look, given that we're heading into summer when I expect surface waters in the ocean get a bit warmer?
Yeah, that's a good question, Rupert. I think the state government had Dr. Don Anson from Woods Hole visit us recently to give to detail some of his extensive experience with harmful algal blooms and Coronia blooms in particular. And from the international experience, it's really uncertain. So whilst we might expect temperature will increase growth rates, there's some other potentially negative factors related to the increased salinity that may influence its growth rates, that may prevent it from impacting certain regions higher up, particularly in Spencer Gulf here, where we get very salty in excess of about 38 parts per thousand to the north of this line that I'm drawing. But then from his experiences overseas, there's been several examples where they've come through one summer into another and the blooms disappeared. So unfortunately, I think there's a role of the ecological balance, whether it's through viral lysis or zooplankton grazing, that remains a big unknown, and I think will be an interesting topic of conversation in the forecasting community about how we do that.
Yeah, Mark, South Australia got advice from people like me and others that said once the ocean cools down and the ocean starts mixing a bit, the heat wave will break. And the heat wave dissipates, the bloom will disappear. And anyone who was basing that kind of expert forecast on physical conditions alone has just been totally wrong, haven't we?
Correct. I mean, I think early on we were hopeful that an increase in mixing, an increase in the flushing of the gulfs, a decrease in the sunlight availability, and eventually potentially these things running out of a nutrient source may be things that would lead to the demise of the bloom. But we have been wrong, and I think that's largely due to some poorly understood or misunderstood ecological interactions or the ecology of the species.
Thank you. Hello, Beryl.
Hi, I'm just wondering whether you want to do the one that's in the chat before me.
No, thank you. I'll come to the chat now when I read it.
Okay, thanks. That was really great, Mark. And my question is about national versus state responsibilities. Obviously, the state government is handling this, but ecology knows no boundaries. I'm just wondering what your thoughts are about it being a national issue rather than a state-based issue.
Well, I think what this example's showing us is no one was really thinking this would happen in South Australia to the extent that this has happened, even though we've had harmful algal blooms before. So to think, to be ignorant enough to think that it couldn't happen elsewhere, when you have a look at global examples, is maybe shooting yourself in the foot. So a little bit. So what do we do to be better prepared? I think it takes a combination of both state and national resourcing. So there's initiative like the ANCOMS initiative. So that's a national approach to coastal ocean modelling that can play a role in improving some of the products that we have here. And there's also initiatives such as IMOS, and it's moving into the coastal space to set up long-term observational platforms that might not necessarily be HAB specific, but provide a lot of the baseline measurements of covariates needed to build HABs, a better understanding of HAB events on better. So I think, unfortunately, it takes a bit of resourcing from both ends to make an impact on these events.
I will still just keep going on the live ones. Hello, Diana.
Hello. Hi, Mark.
Hi,
Fascinating talk. Thank you. We might have to get you to come and give that at the Bureau to get Bureau people excited. So my question is about the ocean forecasting. You're doing 10-day forecasts. Presumably that's using the ocean maps, boundary conditions and Access G. Is that right?
At the moment, we're doing the 5-day forecasts off the ocean maps and the Access G provided by the Bureau. But we're hoping going out in future, we may be able to extend that if we have the forcing available and the right partnerships in place to be able to do that.
Yeah, okay. Because I was wondering if you've done any verifications and if you're seeing any skill out in that longer forecast range. But if you haven't done any, then
definitely not yet, Diana. But I'd expect that
part of the project
decreases with time, as with any forecast.
Yeah. All right. Thanks.
Thank you. Mark Baird, you're next on my screen.
Yeah, hi, Mark. Yeah, I'm interested to see how the bloom moved around the Gulfs. And so I'm just thinking from past years, perhaps it wasn't the same species, but other blooms that have occurred and chlorophyll signals. Have you seen them sort of rotate around the Gulfs in the same way, or do they die out quicker, or?
That's a good question, Mark. Haven't gone back and looked, to tell you the truth. At the moment, we've only really just started to look at long-term climatologies on a monthly scale as part of this response in tracking those time series of tracking the bloom. But no, and definitely we haven't seen anything of this size of a bloom. We do regularly have some smaller blooms beginning the autumn as water comes into Spencer Gulf here, and we know that they get transported northwards along the coast consistent with the circulation, but nothing of the size and duration that we've had with this event.
Right. Thanks.
Hello, Matt.
Yeah, thanks, Mark. It was very interesting. I have a question about, do we know much as to whether it has like a resting stage or a dormant stage, this particular species? I was just thinking about, you were talking about some of the unknown ecological processes. I was wondering if it was, finding some refuge in between ideal conditions.
Yeah, so another good question. When I talk to the HAB experts, there's a little bit of debate about whether the species, the dominant species identified so far, which was originally Mickey Motai, but we're understanding at least as the blooms evolved, it's a bit of a mixed bag of Karenia species. But originally with the Miki Moti, there's some different opinions on the cystic stages and their temporal duration in the benthos. Yeah. But I think that's a part of ongoing research and some surveys that are going to need to be done. And when you have a look at some overseas examples for some species, I believe it's Alexandrium, if I get my information right, that do leave those cystic, then those surveys of bottom surveys are used as an actual an initiation point of forecasting to understand the extent and severity of blooms in upcoming seasons. So it's one part of the science puzzle that still needs to be better understood.
Thanks.
Yeah, I think that's particularly challenging to work out whether the initiation signal is in the water or is it in the benthos. And you could set up an ecological forecasting model that was conditioned on the pelagic. It would be completely wrong if you didn't have the benthic source identified. Yeah, so I hope you're having a bet each way on that, Mark.
Oh, I'll be a rich man.
Yeah. Hello, Claire Spillman.
Thanks, Alistair. Hi, Mark. Yes, you guys have had a busy time. I was just curious about the fisheries that are still closed. If there's any signal or idea about when they might open, along with the ones that were closed temporarily and that have reopened. Were they closed for long? So I was just curious about the fishery side.
Yeah. So this map here is more about the aquaculture, different types of shellfish aquaculture. Okay,
that's what I was meaning.
In terms of fisheries impact, there's a lot of surveys going on now to have a look at the impact on commercial fishery species. But I believe some of that impact's hard to assess because is it a case of the fish have moved or the fish are dead? That's part of the, unraveling the citizen science versus those fishery surveys. There's still, I think, a considerable amount of work there that started but needs to be underdone. In terms of these aquaculture areas, so some of them have been closed. For example, Port Stansbury here on the eastern side of the western side of Gulf St. Vincent has been closed for an extended period of multiple months now since the bloom took hold. Other areas like American River, which is in this little embayment here in Kangaroo Island, have closed and reopened again. And areas around Port Lincoln have closed and have reopened and remained reopened. So a part of those timelines is exposure, of course, to the Karenia and the toxin producing harmful algal bloom, and it's also a result of the testing. So things are closed at a precautionary level because they obviously don't want to have any risk, and then you've got the added delays of being able to have a week's turnaround of getting samples sent to and back from New Zealand before you make decisions as well. So that's why that need for a more rapid turnaround and that capability to do that here, given the importance of these industries for our regions and our regional economies, is so decided about setting up that capability within the state. Does that answer?
That leads on to the other related question I had was just, the event's still ongoing, so it's not like we're reflecting on something that's finished. And there's been new initiatives, under development. What do you think, in your opinion, would have made the biggest difference that you didn't have during the event, that if you did have, in terms of whether it's responding or communication or the political landscape, what do you feel like would have made the biggest difference?
Well, I guess there's probably a couple of things there, in my opinion. I guess what this event has told us is that when the event first took place on the southern Fleurieu here, my team with the EPA was part of the first response to do some sampling. And instantly when I saw some of the pictures, I'm a keen surfer, and I saw some of the pictures and I even felt the impact myself from surfing down there. I went, oh, this is a harmful algal bloom. And I was kind of excited at first because I had a background in harmful algal blooms. Little did I know that was, I didn't predict the impact, and no one did, that this event was going to have. So I think now that we know that precautionary sampling and early detection part of giving a heads up is a vital part of where we're going. I'm not sure. It's going to be interesting with all the resources put into this to see how far we come along in the next few years of research and development to developing improved predictions, whether they be from remote sensing or source point predictions based on the buoy data and the novel sensors that we have. But generally, that communication and the need for integrated tools so that industries and public have more awareness of the situation, it's only shown that needs to be better communicated and more proactively communicated as a constant resource almost.
Yeah. Okay. Thanks, Mark.
Hi, Chow.
Yeah. Thanks, Mark, for a great presentation. I'm just wondering, looking ahead, let's say the bloom finishes next month. Is there a plan to capitalize on this event and to also, considering how you would deal with it in the future? Let's say with an operational information system that you would have your model, you would have the satellite observation, you would ingest the citizen science information, and then you would be able to give early warning. Or I got a bit depressed that you said the onset and the demand, the stopping is impossible to predict, which is would like to predict somehow, but maybe you could have a few days of prediction, right? Say next 5 days, how it will be like. So I'm just curious if there's anybody or some kind of effort trying to set up this kind of information system so that in the future you are better equipped. Also, maybe it can be applied to other areas as well, other jurisdictions.
Sure. So when we have a look at the mooring network with early detection sensors and the integration of different sensors as a broad spectrum ocean color to develop satellite products, the integration of those data into AI forecasts, plus their combination with traditional hydrodynamic models to provide forecasts and early detection. There's definitely a huge initiative over the next 2 years to push as hard as we can in setting up that early detection and developing products as far as we can. And that funding's going out 2 years at the moment. I guess whether that is sustained in the long term or not may well depend on the results that we get and the potential reoccurrence or persistence of harmful algal blooms in our region. At this stage, my hope is that with the initial 2 years of funding, we've got a good impetus to drive some new research and development into this area and apply it to the South Australian region. And hopefully, if we're successful with some of the tools and research that we advance, then that may lead to a broader continuation of those products and development by people outside of us. There's the opportunity to research always piggybacks on knowledge, over time. So hopefully some of the steps that we can make in the first 2 years of funding provide an impetus for further, improvements going forward.
Thank you.
Thank you. Hello again, Rupert.
Mark, you've talked a lot about the importance of forecasting and giving us warning that it's coming, but I'm confused when you're dealing with a force of nature of this scope, what you could let people do apart from just brace for impact for a few extra days.
Yeah. So I guess, Rupert, some of the things there is we can. Sorry, I'm just going to decline a phone call there. We can, at the moment it's let's go one step at a time. I think there's a broader discussion around industry and with fisheries and aquaculture managers, what those mitigation strategies might look like in time. Is that opening up, and I'm going to put out for an example, is that opening up so new areas to be able to conduct aquaculture and move aquaculture? For example, could oysters be moved to a different growing region for fattening up and growing if we've identified an impact? At the moment, I don't think those provisions are there, the space allegations, the legislation to involve those things. So there's also a piece around that for policy makers and managers to look at what are your mitigation means, and again, obviously that comes with an understanding of what are our timeframes of response. So that's where I like the development of some of the more broad spectrum satellite remote sensing, because that should give you a broad spectrum, but it might also have require a higher signal to noise ratio before you get that detection. So there's trade-offs everywhere, but I'm sure this will initiate some policy discussions about what mitigation measures can be undertaken.
Thanks, Mark. Alex again. Hello.
I recently went to a talk sort of looking at the Southern Ocean, where they took water samples and they added nutrients to see what would happen to the water to look at limiting nutrients. Do you do that kind of thing here to sort of try and understand, if you take a water sample and you change the temperature, is that having an effect on the bloom? Or if you change the nutrient supply, what's happening?
Largely no. I think I'm aware of some of those papers earlier on in the days back with the Southern Ocean and iron fertilization and things like that they were experimenting with. No, not in a practical, not in an applied sense in the environment, but I think there's also some learning as part of the response here. There's a need to be able to, as part of the identification of the species that's causing the harmful response or putting brevitoxins into the water, there's a whole culturing and isolation piece that goes on. And I think whilst they behave quite differently in culture than what they do in situ per se, I think there are some lessons that they're learning about different species just around the types of nutrients they might need to add to cultures to get them to survive or grow optimally. And that's not just nutrients, that's also in terms of those environmental conditions, such as the salinity conditions. So how much those lessons from individual culturing carry over into understanding the contributing factors in situ, I don't know. But yeah, I'll leave it there because I don't know.
Mark, obviously this year has led you to spend way much more time on this topic than you ever would have anticipated. So I hope that you're ready to try positing an answer to this question. You're managing a large amount of investment. Do you think the best forecasting breakthrough will come from this first option, that you could forecast any bloom, for example, based on marine heat wave plus upwelling plus Murray River? That's your first option, forecast any bloom. The second one is you want to be able to forecast this species. And then the third one would be, we want to be able to forecast where it goes, given that it's already here. Where do you think the best success is going to come in those kind of three forecasting options?
Yeah, so I think your last one, once it's detected, you've probably got better success in detecting where it's going to go. And there's still lots of room for improvement there. For example, some of the animations I showed you, passive particles put into a hydrodynamic forecast model. And the hindcast models also match up with and the longer term distributions match up with our climatologies or mean circulation. So I think the hydrodynamic models play a key role, and that's why they've obviously adapted worldwide in responding to these events. Putting those better ecological constraints into those are obviously going to refine and improve those models somewhat. For example, I heard from Don Anderson, and I'm sending one of my staff off to a harmful algal bloom conference in Chile shortly, just giving those particles that you put in some biological qualities, whether it's a sedimentation rate or a vertical migration based on the species, does do an improvement in predicting their trajectory. So I think that's the easiest one to do. Now working backwards, I think there are some improvements that can really be done in the satellite space with the newer hyperspectral satellites going up. So from what I understand, the hyperspectral satellites are going to be able to look at smaller wave bands of emission or ocean color. So that gives you the possibility of using novel instruments, whether it's coming from an instrument tuned for two types of species based on fluorescent emission, and some of the most successful products, I believe, in HAB responses have been that normalized fluorescence line height. And as hyperspectral moves forward, there should be improvements in that space. And that's where I'm hoping this combination of hydrospectra and this can be used. But then there's also just the power of large data sets that we haven't had before that are going to obviously make improvements in understanding contributing factors to perhaps forecasting general increases in chlorophyll or blooms in general. So yes, the last one first, and the first two are a work in motion, but I'm confident that there's some improvements that can be made.
Beauty. So you got to three of them. In the chat, Mark Baird says, what about the fourth category, which is the forecasting of ecological impacts given that a bloom has occurred? And you've got a large number. You said 100,550 species affected. Could you imagine an ecological forecast of which species will be impacted by a bloom now that it's present?
Yeah, that's a good question as well. And I think, Beth, you know Simon Goldsworthy quite well. Simon's going to be working with those trophic models. I think it's the EcoSim, EcoPath is his area of specialty. To do some perturbations to those models. Unfortunately, where I think those models might have some limitations is the real fundamental trophic information that we don't have to understand those perturbations. So you might be able to say, oh, we've had a bloom and it's impacted these species. What's the higher trophic levels flow on? But can we go from the lower trophic ecosystem ecology all the way through? Let's see.
Yeah, beauty. And then the fifth forecasting option is that South Australia's received lots of suggestions about how to break up the bloom. And so we could be putting into our hydrodynamic models or ecosystem models what is it called? I suppose the mitigation or intervention that's being proposed, like a toxin or a scrubbing it out or that kind of thing. So that's a fifth area of forecasting, I suppose, too, Mark.
Yeah, so I know there's been conversations around mitigation technology such as clay that they use in China and overseas quite a bit. And those discussions need, regulatory approval. They need testing here, working from small scale until you even get into an applied sense, and then applying them in over the areas and in the ecosystems that we've got. Especially these tidal estuaries where we can get current speeds up to 1 to 2 meters a second in different places, and how you would apply them and control them. Obviously, our hydrodynamic modeling plays a role in being able to understand how to optimize those strategies if they get to this, approved to the scale that you could use them in an in situ applied sense. So I think there's a little bit of work to go there first.
It's such a tremendously rich area for forecasting, and I know that there's plenty of scientists around Australia really committed to helping with this particular problem. And on behalf of the audience, I'd just like to thank you very much for talking to us.